Alright, continuing on from our last video, we're looking at example 3 of our 3-variable systems. So example 3, we're going to look at the system 2x minus 5y minus 6z equals 57, negative 4x plus 7y minus z equals 19, and 9x minus y plus 4z equals negative 75. Now, one way to think about which variable you want to eliminate to start is when you look at this system, where do you have some positives and some negatives in the same variable? For this particular system, what I'm going to do is start by eliminating my z's, and I'm going to start by looking at these first two equations, and I'm going to multiply the second one by negative 6. So we're going to end up with 2x minus 5y minus 6z equals 57, and then we're going to have 24x minus 42y plus 6z equals 114. So now we can just add going down. Our z terms are gone. We're going to have 26x minus 47y equals, in fact, I forgot to put a negative on my 114, so let's take care of that, because I had a negative and a positive. Glad I found that before I kept moving on. If we combine that with 57, we're going to get negative 57. Now I'm going to do the same thing. I'm going to eliminate z, but this time I'm going to look at the last two equations, and instead of multiplying the second equation by negative 6, I'm going to multiply it this time by 4. So I'm going to rewrite that first one, third one, 9x minus y plus 4z equals negative 75. We can do that. And then I'm going to multiply everything in that middle equation by negative or positive 4. So we're going to have negative 16x plus 28y minus 4z equals 76. So now we can combine our equations. The z's cancel out. 9x minus 16x is negative 7x. We're going to end up with a plus 27y equals 1. So we've got our system, that equation we just found, and we've got 26x minus 47y equals negative 57. We can choose to eliminate the x or the y. In this case, I'm going to do the x's, but you can go ahead and do the y's. They both have one that's positive, one that's negative. So to eliminate my x's, I'm going to multiply the entire first equation by 26 and the second one by 7. What that's going to give me is 182x, negative 182x, plus 702y equals 26. And then with the second equation, we're going to end up with 182x minus 329y equals negative 399. So combining these, the x terms cancel out. We're going to end up with 373y equals negative 373. Divide by 373. we're going to get y equals negative 1. So now we're going to take that into one of the equations and figure out x. But I've run out of space. So I'm going to actually use this equation to figure out x. So we've got negative 7x plus 27 times negative 1 equals 1. So we can clean that up. Negative 7x minus 27 equals 1. If we add 27, we're going to get negative 7x equals 28. We can then divide by negative 7 and get x equals negative 4. So we've got x, we've got y equals negative 1. We're going to take and plug those into, again, I'm just partial to the first equation, so we're going to go 2 times negative 4, 2x, minus 5 times negative 1, minus 5y, minus 6z equals 57. So cleaning this up, taking care of the multiplication, we're going to end up with negative 8 plus 5 minus 6z equals 57. So we can combine negative 8 and 5, get negative 3 minus 6z equals 57. If we add 3, we're going to get negative 6 times z equals 60. So divide by negative 6, we're going to get z equals negative 10. So our ordered triple is going to be negative 4, negative 1, negative 10. All right, let's look at example 4. So we're going to have the system 4x minus 5y plus z equals 20. We're going to have 6x minus y minus 2z equals 35. Negative 2x plus 8y minus 3z equals negative 9. And I'm going to start by eliminating a variable in the first two equations. And I'm going to eliminate my y's when I do this. You could also go and eliminate your z's. That's fine. In fact, that's probably a better idea because I see my z's, I've got one that's positive and one that's negative. So I'm going to multiply my entire first equation by 2. So I'm going to have 8x, not 4x, minus 10y plus 2z equals 40. And I'm going to have 6x minus y minus 2z equals 35. Now we can add going down. Our z terms are gone. 8x and 6x is 14x. Combine our y's, get negative 11y equals 40 and 35 makes 75. Now I could take any combination of that last equation and the first two. I'm going to look at the first one and the last one. And I'm going to eliminate my z's. This time, instead of multiplying by 2, I'm going to multiply by 3. So we're going to have 12x minus 15y plus 3z equals 60, and negative 2x plus 8y minus 3z equals negative 9. The z terms cancel out, and now we can just add going down. We're going to have 10x. We're going to have minus 7y equals equals positive 51. So my system I'm going to look at is going to have 14x minus 11y equals 75, and 10x minus 7y equals 51. I'm going to multiply I'm going to eliminate my x's. Now I could just go and multiply the top row by 14 and the bottom by 10. That would be fine. But I also know I don't need to go that intense. I can instead multiply the top row by 7 and the bottom row by 5. Because I know 2 goes into both 10 and 14. So I'm just not going to worry about that. They're both evens. We're just going to multiply by what factor each one has that the other doesn't. So my new top row is going to be 70x minus 49y equals 357. And then my bottom row is going to be 70x minus 55y equals 375. Now let's just subtract the bottom row. So our x's are gone. If we subtract a negative, we're just changing the signs, that means. So we're going to end up with 6y equals negative 18. If we divide by 6, we're going to find that y is equal to negative 3. So now we're going to take one of those two equations in our second system we made. I'm going to take the 10x equation, plug negative 3 in to figure out x. So we know that y was negative 3. If I go 10x minus 7 times negative 3, we know that should equal 51. Negative 7 times negative 3 is going to make 21. So we're going to have 10x plus 21 equals 51. If I subtract 21, I'm going to get 10x equals 30. Divide by 10. We're going to get x equals 3. So now I'm going to take the y and the x, and I'm going to just go with the first equation. 4 times 3 minus 5 times negative 3 plus z equals 20. Well, 4 times 3 is 12. Negative 5 times negative 3 plus 15 plus z equals 20. 12 and 15, if we combine them, makes 27 plus z equals 20. So if I subtract 27 from both sides, we're going to get z is equal to negative 7. So our ordered triple is going to be our x, 3, our y, negative 3, and our z, negative 7. I do believe we have enough time to also get example 5 in to this video. Example 5, we're going to look at the system 8x minus z equals 7, 4x plus 3y equals negative 31, negative 7y minus 2z equals 73. Now I'm going to take the bottom two and I am going to rearrange things so my x's and y's can line up, my x, y's, and z's, and I can add terms to this as well. So I'm going to rewrite the top equation as 4x plus 3y plus 0z, that hasn't changed my equation, equals negative 31. Now with the second equation, I'm going to have 0x minus 7y minus 2z equals 73. I'm going to eliminate my y terms. So I'm going to multiply this entire first equation by 7 and the bottom one by 3. So we can rewrite this now as 28x plus 21y plus 0z equals negative 217. And then our second equation, we're going to still have 0x minus 21y minus 6z equals 219. And we're going to add down. Our y's cancel out. We'll have 28x minus 6z equals 2. Since this equation and the first one are in terms of x and z, we can utilize those two equations now to figure out our x and z terms. So I'm going to go and multiply this second equation, which is my original first equation, by negative 6. So let's rewrite this. We've got 28x minus 6z equals 2. Then we've got negative 48x plus 6z equals negative 42. My z terms are going to cancel out. We're going to get negative 40 on the right. If I combine my x terms, we're going to get negative 20x. So if we divide by negative 20, we're going to find that x, I'm going to put it over here on the left side of the screen, x is equal to 2. So now we're going to take that into, let's say, our very first equation in our system to figure out z. So we know x is 2. If we go 8 times 2 and subtract z from it, we should get 7. Well, 8 times 2 is 16, minus z equals 7. So if I subtract 16, we're going to get negative z equals negative 9, which means z is equal to 9. So x is equal to 2, z is 9. We can also take the x and put it into that second equation. 4 times 2 plus 3y. If we do this, we can solve for y. That equals negative 31. Well, 4 times 2, that's 8, plus 3y equals negative 31. If we subtract 8, we're going to get 3y equals negative 39. When we divide by 3, we're going to get y equals negative 13. So our ordered triple is going to be our x was 2, y is negative 13, z is 9. Now we don't have time to throw in any application problems yet, so that's going to go into our next video.